Hello, in this video we are going to keep working on Cubethon, and what we're going to do now is see if we can get the player to respawn or get the scene to reload if the player falls off the board. And that's going to require us to go into our player script and edit it just a little bit more. No, can I zoom in on this? No, parent editor layout. Zoom in. There we go. There we go. That should be a little bit easier to read there. Okay, so let's add a reset function. So I'm going to give myself some space here, and notice that the curly brace layout is a little bit different in mono develop. I think they've kind of borrowed that standard from JavaScript. I don't particularly like it. So let's add a function called reset, and let's make it public, just in case somebody else needs to reset the game. And let's make a function called public void reset. And in here, what we're going to do is tell the scene manager to reload the game. So we imported that scene manager class the very first step, and if we hit the dot operator, we can see what functions are in our scene manager. And if we kind of scroll through here, oh look, load scene. Okay, let's call our load scene function, and now we have to tell it what scene to load. And this takes a string, so we have to give it the name of the scene to load. So let's put in here, how can we get the active scene? Well, let's ask the scene manager for the currently loaded scene and then get its name property. Scene manager dot, oh there we go, get active scene. Is that a function? That is a function, gets the currently active scene dot name. Right, so that gets the name of the currently loaded scene right here. And I don't know where my mouse keeps going. That gets the name of the currently loaded scene and then loads it. So let me save my file here. There we go. Okay, so we are now saving our scene. And then let's add another function to call that reset function if the player has sort of fallen off of the world. So we could do that here in the update function, but there's another function that we can actually take advantage of to just to kind of keep things separate here. There's a function called fixed update, which also runs almost every frame. So let's add the fixed update function here. There's also a late update function. Think about GameMaker. We had begin step, step, and end step. That's kind of like what's going on here. So what we can do is just check our y coordinate, and if it's like something lower than what it should be, like if it's not 0.5, that means the player fell off the board. So let's just arbitrarily say, okay, well if it's less than negative 100, like now the thing's been falling off the board for a while, let's call our reset function. So, and what that's going to do is reload the scene. So if the player, every frame the player is going to be seeing, hey, or checking, hey, have I fallen really far off the board? If I have, call the reset function. The reset function is going to say, hey, tell the scene manager to get the current scene and then get its name, and then reload the scene that has that particular name. So that's all that's going on there. Let's just try that out and see if that works. So my mouse keeps disappearing because mono develop is awful. And let me go here and let's run this and just see what happens. All compiler errors have to be fixed. Y does not exist in the current. For love of God. Okay, so Y, where is Y? The Y coordinate for this object is in the transform. Transform dot position dot Y. There we go. Okay, so let's look at that object. You can see the object has a transform. The transform has a position. The position has a Y. There we go. So to access that, I have to say transform.position.y. And then let's save that. And let's test it out. So the thing goes flying, and let's steer it off the board. And its Y coordinate is now less than 100. And it reloads the scene. Okay, but something very weird just happened there. You can see how the world went dark. This is kind of I don't want to say a bug. It's a bug in Unity. And it has to do with the lighting. So the way you fix this is you have to come to the window menu and go down to lighting. and let's uncheck automatically this automatically build the lighting thing, and click the build button and say save scene, and we'll call it scene 1. And I think we should be good there. And let's run that and see if it works. So now when this guy goes flying off the board, 3, 2, 1, it should pop back and the world should stay. There we go. Okay, so we got that lighting bug fixed. All right. So you can see how Unity is now reloading the scene, and we can sit here all day long. Wee, that's fun. Okay, and so we're good to go there. Okay, now let's make some obstacles. Obstacles are just going to be cubes as well. And let me just start by saying, okay, I want a 3D object, a cube, and now this cube may look enormous, but that's just an illusion caused by the fact that we're looking at a 3D scene on a 2D screen. And Unity seems to put things at random coordinates when they are created. However, if we put this thing at x of 0, it'll be in the center of the board. If we set our y to 0.5, it'll snap down to the board, and then the z, we'll figure that out in a second here. So now we can kind of move this thing around here. There's an obstacle, and let's see. I think if I put it at 3.5, it'll be right on the edge of the world. There we go. That looks pretty good. Let's zoom in on it. If I double click on this cube, you can see we get taken over to it. And let's make it blue. So I'll just drag my blue material over to it. And let's see, we've got a box collider there. I don't think we have to do anything. I think we don't have to tag this. We don't have to, it's got a box collider on it already, so we don't have to do that there. And let's try to make some patterns of these cubes here. So if I take this guy and duplicate it and move him over here to say, like, negative, maybe negative 3.5. Wait, no. So now he's on the other side of the world. What I can do is I can take these guys here and I can put them inside a common parent, and then anytime I want to have a pair of obstacles like that, I can just clone that out. So let me make a new. Let me right click on this guy and say create an empty object. So now I've created an empty object where that guy is. And now if I drag this guy off, he's now separate. And then what I'm going to do is drag the two children here, and I'm going to attach them to the parent. So now I'll call this, like, pair of cubes. So what I have now is an empty object called why didn't it take my... What I now have is an empty object that's got cube and cube 1 as children of it. And now if I wanted to make another one of those things, I can just right click on that and say duplicate and then slide it down. And you see I've got these grid lines here. I can use those to kind of line stuff up, just to duplicate and slide. So all right, now, I mean, we could do, there's lots of stuff you can do with the cubes. We could make, a group of 3 of them. Let's, duplicate this guy, and then I'll call this like 3 cubes. I'll make a group called 3 cubes. And let me expand that here, and this guy, cube 1, let me duplicate him. And you can see he's now a child of 3 cubes here. And let me go and set this guy's x coordinate to 0. What does that work? No. I can put him in the middle there. So now you can see so now I've got a new type of obstacle here. I've got an obstacle called 3 cubes, and now I can duplicate that, right? And move that whole thing down. Right, or I could put 2 in the middle. That would be kind of cool too. So you can see I can create all these patterns and try to run through them. But I've got this problem here now about, like, the camera is not really following is not really following the player yet. So let's figure out how to do that. Well, I guess there's a couple of things we could do. Let's see if we can first get the collisions with the obstacles working here. So what do we need to do to detect the collisions here? Let's open up our player script again and add another function. And because our player has a rigid body component on it, the player can will be notified of collisions with other objects. So let's add a function here called onCollisionEnter. OnCollisionEnter is this is like our mouse click or our paint event functions in Visual Studio when we were doing C#. OnCollisionEnter it's an event handling function that responds to a collision. And it takes a parameter which is an object called a collision. So there's an object that represents a collision. And when the collision happens, we will be notified. And it's got to return void. There we go. So this function will be called when a collision occurs between whatever object the script is on and another object. So what we want to do is make sure that the thing that we're colliding with isn't the floor, because we're always going to be colliding with the floor. So what we need to do is figure out, somehow get the other object that we collided with and check the tag on that object. So how do you get the tag off of the thing we hit? Well, in GameMaker, remember we had this other thing, it was the thing that you hit. That's what this is. This collision object has in it as a variable the thing that we hit. So let's take a look in this collision object and see what's in there. You can see there's a game object. That's the object that we hit. And what does a game object have? Well, a game object has a tag, and we can check it to see, okay, so if it wasn't the floor, well, then we must have hit an obstacle. So if it wasn't a floor, then what do we want to do? Let's set our alive variable to false. So now we're not going to be controllable anymore. And then let's call our reset function. But we don't want to reset right away. We want to reset after a delay. So how do we call the reset function after a short delay? We can use a function called invoke. Invoke is like an alarm in GameMaker. It's like saying, hey, call this function in a couple of seconds. And it takes two parameters. One is the name of the function to call, and then a number that represents how long to wait before calling that function. So the function that we called was we want to call is reset, and let's call it in 5 seconds. So we'll say 5.0f. It's 5.0 is a floating point number. We could probably just pass in 5. That would work too. So now we're saying if we hit something and it's not the floor, now we're not alive anymore. Call the reset function. So let's just see if we can hit a cube and see if it resets the game. Yeah. What? Uh-oh. That did not really hit a cube there. There we go. Boom. Okay, so you can see that we stopped and it reset the game. Boom. All right, so there we go. All right, so now we still have this problem though that the camera is not really tracking the player. So let's see if we can get that fixed now. That's going to require another script. So I'm going to go into the scripts folder here and I'm going to make a new script called camera that we're going to put on our camera to tell it to track the player. So this is not going to be a very complicated script. The camera is not super smart in this particular project. So let's open up our camera script here. And what we're going to do is just check our distance from the player on the along the z-axis, and if it exceeds a certain distance, then we're just going to say go to wherever the player was, or set our z-coordinate to the player's z-coordinate minus whatever the following distance is, minus however far we're supposed to stay back from the player. All right, so now we've created a script called camera. Let's make a variable called following distance. It'll be a floating point number. It could be an integer. It really doesn't matter. Following distance, and we'll set it to, I don't know, 5.0f. So the camera is supposed to stay 5 units back from the player. And let's let's make a variable to store a reference to the player object. The player is a game object called player. And you can see, so when we're not giving it a value here, so when the script starts, that variable is going to be null. In the start function here, we're going to go look up the player object. We're going to ask Unity, hey, go find me the player object and assign it to our player variable. So we'll use the find game object with tag function to do that. So to find an object by its tag, you have to say game object dot find game object with tag. Find game object with tag. There we go. And then say what tag you want to find. Be careful. There's a function called find game objects with tag that returns you an array of objects. We just want the singular version without the S. We just want it to return one object. So go find me the object with the player tag on it. So now in the start function, we've got a reference to the player, and now we can always check to see how far away the player is. Okay, so now let's go down to the update function. The update function runs every frame. What we're going to do is figure out where the player is and subtract off the following distance, and then that's where the camera is supposed to be. So let's first check to see if the player is like too far, is far enough away that the camera now has to start moving. The whole point of the script is just to kind of keep the camera at the same distance relative to the player, but also it's going to give the player kind of there's going to be some lag involved here, so the player can accelerate a little bit before the camera starts tracking it. So let's check to see how far, if the distance between the player and the camera is greater than this following distance. So we can check how far apart they are by comparing their z coordinates. So if the player's transforms z position minus this object's z position, because this object is going to be on the camera, which is transform dot position dot z. So if the distance between the player and us along the z-axis is greater than the following distance, well, now we want to figure out where the player is and then go to that place, but then back up by whatever the following distance was. So let's first of all figure out where we are here. Let's make a vector 3 called p, and that p is just for position, and we'll set it equal to wherever we are, which is our transform dot position. So that's our position, and what we want to do is we don't want to change our x and y. The camera never moves up or down. It never moves left or right. All it does is move forward, backward. So all we want to do is change the z coordinate in the vector 3 here, in our position. We just want to move forward, backward. So we're going to leave x and y the same and just set the z coordinate equal to whatever the player's z coordinate was, and then minus the following distance. So figure out where the player is and then back up. And that's going to be player dot transform dot position dot z. So then minus however far we're supposed to stay back. And then now we've got this vector 3, right? This position, which is storing an x, y, and z, now has where we are left and right, and then also where we're supposed to be along the z-axis. And now we just need to set our position to that. Transform dot position dot z equals p. You cannot just change the x, y, or z of something's position. It just doesn't let you. So you have to create a whole new vector 3, a whole new position in space, and then assign that to the transform's position. That will, in fact, move you. So now let's try to run this here and see if it works. So this just says figure out where we are, and then adjust our z coordinate, which is our forward backward coordinate, to keep back from the player by however far we're supposed to stay back. So let's go to our camera here and close the lighting tab. Let's put that script on the camera. Can I drag it up there? No. I could certainly put it, I can just drag it over there, and you can see now we've got Compiler errors need to be fixed. Oh, come on. And transform does not contain a definition for z. Transform.z. Transform.position.z. Transform.position.z. All right. Transform position z. Okay, so the camera, so you can see there, as soon as the cube starts getting too far away, the camera starts following it. And that was pretty good, actually, for a first try. You know, what I might do is raise the camera up just a little bit. I don't know, I mean, this is just kind of personal preference, and maybe rotate it down a little bit. You know, or maybe it was fine the way it was, I don't know. Right, and if I fall off the side, now, once that thing gets below 100, we start the countdown timer. There we go. Okay, so one last little cosmetic thing here. It looks like we have, you know, we are missing a skybox in this project, and that looks kind of crummy. So you can go into the main camera here, and instead of saying that we want to use a skybox, we can just say use a solid color. And we can come in here, we can pick a blue. And now when we run this, you'll see that it's not going to show a skybox. We've got the blue color right there. So there we go. So there's some progress. I'm going to stop right there, but in the next video, I'm going to show you how to make the end zone. I'm not really going to show you how to make all the obstacles. I'm going to leave that up to you. Also, the force variable here on the player is public, so you can go in there and change that. If you're like, oh, that was too slow, go in here and change it to 1,000 and see what effect that has. Right? Whoa. Okay, that's what effect it has. You see, now it's much faster. So it's up to you. You know, it's your game, your way. So in the next video, we will make the end zone that the player is trying to reach. I'll leave creating the specific obstacles up to you. And if you have any questions on how to get that to work, just ask and I'll be happy to help you.